Good morning, students. Now we can see basic signal operations. Basic signal operations we can do in two ways. Okay, one is depending upon the independent variables, another one based on the dependent variables. Okay, for independent variable means only the y-axis is going to be changed depending upon the operation of the signals. The dependent variable is nothing but the signal is going to be changed depending upon the x-axis. Okay, so first we can see independent variables, how the operations are performed. Amplitude scaling of signals, addition of signals, multiplication of signals. These are the three operations performed depending on the y-axis. First one, amplitude scaling of signals. Amplitude scaling is a very basic operation performed on signals to vary its strength, whether the y-axis is going to be compressed or it's going to be expanded, or another way we can call it as a attenuated or amplified. Okay. The general mathematical representation for amplitude scaling is y of t is equal to alpha x of t. So alpha is nothing but scaling factor. Okay, here consider any signal x of t. If you want to attenuate this signal, you take the alpha value is less than 1. So if alpha is less than 1, it is attenuated. If alpha is greater than 1, it is amplified signal. Is it clear? Now, you look at it. If alpha is taken as 0.5, what will happen? The original amplitude gets reduced exactly half. You look at the amplitude is 0.5. So, if you compare x of t and y of t, this is called attenuated signal. It is meaning is attenuated. This is attenuated signal. Okay. The next one, if alpha is greater than 2, for example, if alpha is 1.5, what will happen? The signal x of t multiplied in the y direction by 1.5. So you will get the answer is this one. Compare x of t and y2 of t. y2 of t, the y direction is higher than the original signal. So this is called amplified signal. Okay, this is amplified signal. This is nothing but amplitude scaling of signals. So this is the example for discrete time signal. This is x of n. Here the scaling factor is 3. So if the alpha is greater than 1, what will happen? Compared to the original signal. Okay, so this is amplified signal. Here alpha is less than 1. What will happen? Compared to the original signal, the signal is attenuated. Okay, exactly the amplitude is half. You compare the x of n and this attenuated signal, no changes in the x direction, only there is a changes in the y direction. So y direction is nothing but independent variable. So next part is addition of signals. Addition of signal is nothing but, okay, we are going to add two signals. This operation involves the addition of the amplitude of two or more signals at each instant of time. So we have to consider t equal to 0, 0 0.5, 0 0.6, 0 0.7, 1, 2, like that. Each and every value of t, okay, you have to see the first signal and the second signal, add the amplitude and mark in the final output. So x1 of t is given, x2 of t is given. Okay, first you take a t equal to 0, both. Okay, here at t equal to 0, the amplitude will be 2. What is the amplitude here also? At 2. 2 plus 2, the amplitude becomes 4. Okay. Now, next you take minus 1. Here minus 1, the amplitude is 1. Here minus 1, the amplitude is 1. 1 plus 1, what will be the amplitude? It becomes, sorry, here 1 at minus 1, the amplitude is 2. Minus 1, the amplitude is 2. 2 plus 2, it becomes 4 at minus 1. Okay. Next, you take minus 2. Minus 2, what will be the amplitude? 0. At minus 2, the amplitude is 2. 2 plus 0, the amplitude becomes 2. Okay. So, whatever the changes you have it in the signal that can be added it here, you will get like this. The same thing you have to do it for the right side. At each and every instant of time, you mark it, draw the final version of the addition of signals. This is for discrete time signal. X1 of n, x2 of n. At each instant of time, you add the amplitude of x1 and x2, you will get answer of x3 of n. Is it clear? For example, at 0, okay, here the amplitude is 2. What is the amplitude? 3. So, 2 plus 3, you will get the amplitude is 5. At 0. Similarly, at 1, what is the amplitude? Minus 1. Okay. Here 1, it is 2. So, minus 1 plus 2, you will get amplitude is 1. So, now the instant is 2. Okay. 2, 2. At 2, what will be the amplitude? 3. At 2, what will be the amplitude? 1. 3 plus 1. At 2, the amplitude is 4. Is it clear? The next part at 3. At 3, what will be the amplitude? Okay, at 3, the amplitude is 2. Here, no 3. So, you assume as a 0. So, you add 2 plus 0. Okay, you will get the amplitude is 2 at 3. Now, you come to 4. What will be the amplitude? 1. Okay. Here no 4, 1 plus 0, you will get 1. Similarly, we have to do the negative cycle also. The next one, multiplication of two signals. So, multiplication is nothing but consider two signals, you do the product at each instance of time. Okay, you take x1 of t, you take x2 of t. Okay, you at each and every instant, what will be the amplitude? Multiply the first signal amplitude and second signal, mark it in the final output. For example, here at 0, the amplitude is 2. Here at 0, the amplitude is 2. 2 into 2, the amplitude becomes 4 at 0. Okay. So, like that, we have to take each and every instant, okay, both signals, this amplitude and this amplitude is multiplied. The final answer is marked here. Now, you join the lines, okay. The next one, this is the discrete signal to perform the multiplication operation. Okay, x1 of n, x2 of n, product of these two will be x3 of n. At 0, the amplitude is 3. At 0, the amplitude is 2. 2 into 3, the amplitude becomes 6 at 0. Okay. Now you take at 1, the amplitude is 2. Here at 1, the amplitude is minus 1. Minus 1 into 2, minus 2. Okay. Then you take 2. What is the amplitude? 1. Here what is the amplitude? 3. 3 into 1, okay, at 2 the amplitude is 3. Now at 3 what will be the amplitude? 2. Here no 3, it is 0. 0 into 2 it becomes 0. Okay, so like that you can proceed in the right side. Similarly for the left side at each and every instant of time. The next one is the problem combination of all the three operations we are performing here. Consider x1 of n and x2 of n. Okay, we have to perform x1 of n plus x2. So this is nothing but addition. This is nothing but subtraction. The third one is nothing but the multiplication. So how do you perform the addition operation? x1 you have, x2 you have. Both the signals are graphically represented here, x1 and the x2. Now at each and every instant, okay, the x1 of n and the x2 of n added, the result will be obtained here. This is for addition of two signals. Similarly, for the second case, we have to do the subtraction. So, x1 minus x2 get the output at each and every instant. Similarly, you multiply both the signals, you will get the final answer. Okay, you take at 0, what will be the amplitude? 3. Here 0, what will be the amplitude? 3. So, you will get at 0, 3 into 3, you will get 9. Like that, at 1, what is the amplitude? 4. At 1, what is the amplitude? 5. So, 4 into 5, the amplitude becomes 20. So, like that, each and every instant of n, see the amplitude, multiply with the x1 of n, you mark it in the graph. This will be the final result. Okay, thank you.